helping to demystify many unknowns about what goes underneath the depths of ice in Antarctica. Scientists say this is because the lake has been isolated from the usual sources of atmospheric-derived energy, such as photosynthesis, for millions of years. They believe the ice is a good environment for primitive bacteria, and that the bacteria need less food because the surroundings are cold. Also, the metabolism is reduced like that of a hibernating bear. Another finding from the study of the DNA data extracted from the microbes is that there is only a few known bacteria subgroups. The most important question that has bothered scientists for years is, how do the bacteria get energy to survive? Don't you think it's worth knowing? How can these organisms stay alive for years in such an environment? A possible answer could be that they have adapted to that environment. While this is true, we are merely scratching the surface. The bigger fish to fry is, what makes them able to adapt to such an environment in the first place? The search for these answers has led scientists to keep investigating the lake. A terrifying discovery from Lake Vostok that shook the scientific community is the 2013 unearthing of unique DNA sequences from the lake. The facts derived from this investigation continue to shock scientists till today. They didn't expect to come across such spine-chilling scientific discovery in the depths of Lake Vostok. For a long time, many scientists had believed that the subglacial cannot host any form of living organisms. And when you look at it, it wasn't wrong to hold such beliefs then. This is because the available evidence indicated that Lake Vostok was inhospitable. This highly esteemed scientific opinion came crashing down after digging out coarse sections from deep layers of the ice and studying them. These layers were removed from ice accumulated from lake water that froze onto the bottom of the glacier where it meets the lake. The unearthed ice sections were as clear as diamonds and formed at the great pressure and relatively warm temperatures found at that depth. Scientists took sample cores from two areas of the lake, the southern main basin and near an embayment on the southwestern end of the lake. Since we are speaking of scientists, you should know that Dr. Scott Rogers of Bowling Green State University led the team. Rogers is the senior author of a paper that reports the findings in PLOS1 journal. The scientific team found more than 3,000 known bacteria, including the ones found in the digestive systems of fish, crustaceans, and annelid worms. They also identified fungi and 2 species of archaea, single-celled organisms that tend to live in extreme environments. The search didn't produce only this because the team also discovered other species associated with habitats of lake or ocean sediments.